Hi everyone. Today we're going to study factoring. Specifically, this is factor the greatest common factor, GCF, from a polynomial. First, let us define greatest common factor. The greatest common factor, or GCF, of two or more expressions is the largest expression that is a factor of all the expressions. How to find the greatest common factor? We're going to follow some steps. Step 1. Factor each coefficients into primes. Write all variables with exponents in expanded form. Step 2. List all factors matching common factors in a column. In each column, encircle the common factors. Step 3. Bring down the common factors that all expressions share. Step 4. Multiply the factors. Let's have an example. Find the GCF, or greatest common factor, of the three terms. 21x cubed, the second is 9x squared, the third term is 15x. In step 1, let us factor each coefficients into primes. We write all variables with exponents in expanded form. So the 21x cubed is now factored out into 3 times 7. That is the prime factors of 21. And for the x cubed, we are going to write the x here 3 times. For the 9x squared, this is equal to 3 times 3 times x times x. For the 15x, this is equal to 3 times 5 times x. Step 2. List all factors matching common factors in a column. So the factors are now written like this. For the common factor 3, it is written in one column. There is also another common factor of x written in another column. It says in each column, encircle the common factors. So we encircle the 3, the common factor 3, and also the common factor x. Step 3. Bring down the common factors that all expressions share. So the 3 is brought down here, also the x. And then the step 4, we will multiply the factors. So the greatest common factor equals 3x. Let us go to factoring. What is factoring, by the way? Splitting a product into factors is called factoring. Example, find the factors of 6. It is showing here that the factors of 6 are 2 and 3. We know that there are other factors like 6 times 1 for this number 6. However, for this topic of factoring, we will only consider prime factors. Let us note that prime numbers are integers greater than 1 whose only factors are 1 and itself. Examples are 2, 3, 5, 7, 11, 13, and so on. Let us discuss now factoring the greatest common factor from a polynomial. We're going to follow some steps. The step 1 says, find the GCF, or the greatest common factor, of all the terms of the polynomial. Step 2, rewrite each term as a product using the GCF. Step 3, use the reverse distributive property to factor the expression. Step 4, check by multiplying the factors. Let's have example 1. Factor the trinomial 6x cubed minus 9x squared plus 12x. Our step 1 says, find the GCF of all the terms of the polynomial. In here, the GCF is 3x. Looking at the numbers 6, 9, and 12, the greatest common factor of these three numbers is 3. For the variables x cubed, x squared, and the x, the greatest common factor is x. So the GCF of this trinomial is 3x. Step 2, let us rewrite each term as a product using the GCF. It means we're going to split each term. Look at the first term. The 6x cubed is split into two factors in such a way that one factor should be the GCF. So the 6x cubed is now factored out into 3x and 2x squared. The second term, negative 9x squared, is now factored out into negative 3x, the GCF, times the 3x. For the 12x, the factors are the GCF 3x and the number 4. For step 3, use the reverse distributive property to factor the expression. It means to say we're going to remove first the GCF from the three terms. So see, the GCF is now outside, and then on the second factor, we're going to collect all terms that will remain for each term here after removing the GCF. Look at the first term here. After removing the GCF, the 2x squared remains, so it is written here 2x squared. For the second term, after removing the GCF, only the 3x is coming, so this is minus 3x. And then plus. For the third term, after removing the GCF, only the number 4 remains, so we will copy here 4. Step 4, let us check our answer by multiplying the factors. We should go back to the original problem after the multiplication. So the 3x multiplied by the 2x squared, I will get that 6x cubed. And then the 3x multiplied to negative 3x, the answer is negative 9x squared. And then 3x times 4 is positive 12x. So we are sure that this is correct, and this is our final answer. Let's have the second example. In here, there are two big groups. It is a difference of binomial. Look at this first group here. It is a product of 3y times the quantity y plus 7, and then minus. The second group is 4 times the quantity y plus 7. Let us go to our step 1. Find the GCF of all the terms of the polynomial. So our GCF is this y plus 7. That is the common in the first group and in the second group. So I wrote here the GCF, that same y plus 7. Step 2. Rewrite each term as a product using the GCF. In this problem, it is already in the form of a product in such a way that one of the factor is the GCF. So we just copy that same problem. In step 3, use the reverse distributive property to factor the expression. So we're going to remove first the GCF. So removing the GCF here, we expect two terms in the second factor. In the first blank here, I'm going to write the remaining term after removing the GCF. So looking at this first group, I can see here that 3y will remain after I remove the GCF. So I will write the 3y. And then plus. For the second blank, I'm going to write here the remaining term after removing the GCF. So that is the negative 4. So negative 4 will come down here. So this is plus and minus. I will simplify this into negative 4. And step 4, let us check by multiplying the factors. So we want to multiply these factors and hoping that we will get back the original problem. So the first group is this 3y times the GCF. So this is our 3y. If I multiply by the first group or the GCF, I will get the first group here. And then this negative 4 multiplied by the GCF here, I will get the second group, the negative 4 times the quantity y plus 7. So now I am sure that this answer or these factors are correct, and this is our final answer. Hi everyone, today we're going to study factoring. This time we're going to factor by grouping. How to factor by grouping? We're going to follow these 4 general steps. In step 1, we're going to group terms with common factors. Step 2, we will factor out the common factor in each group. Step 3, factor the common factor from the expression. Step 4, check by multiplying the factors. Let us have example 1. Let's factor out these 4 terms, xy plus y plus 2x plus 2. In step 1, we're going to group terms with common factors. So I'm going to group the first 2 terms, xy plus y, and the last 2 terms, 2x plus 2. In step 2, factor out the common factor in each group. In the first group, the variable y is common, so I'm going to factor it out. So y comes out. What remains inside is the x plus 1. For checking, I'm going to multiply this y to this x, so I will get back the xy, and then y times 1 is y. So I'm sure that this is a correct factors for the first group. In the second group, the common is the number 2. So I'm going to bring out that number 2, and what remains inside is the x plus 1. So checking again, 2 times x is 2x, 2 times 1 is 2. So I'm sure that this is a correct factors for the second group. In step 3, factor the common factor from the expression. We have now here two big groups. For each group, the common factor is the binomial x plus 1. So I'm going to bring out that common factor outside. So it is now x plus 1. Since we have two big groups, the second factor should be a binomial also. So I'm going to collect all the terms that will remain after removing the common factor from each group. So in here, it is y, and then plus the 2. In step 4, let us multiply the factors to check if our answer or if the factors are correct. So x multiplied by y, I will get that xy. X times 2, I will have this 2x. And then 1 times y, will get back that y. And 1 times 2 is 2. So these factors are the correct answer. Let us have example 2. 2x cubed minus x squared minus 10x plus 5. Step 1. Group terms with common factors. So I'm going to group the first two terms and group the last two terms. But you see here, our third term is negative. So while putting the grouping symbol, I should write here the plus and then put the last two terms in the grouping symbol. In step 2, factor out the common factor in each group. The common is the x squared. So I'm going to pull out the x squared. So what remains will be 2x minus 1. In the second group, the common is 5. But I should write negative 5 so that later the binomial here will come to be on the same value with the 2x minus 1 of the first group. So if I pull out the negative 5, what remains here is the 2x minus 1. Before going further, I must check myself if the factors are correct. The negative 5 multiplied by 2x, I will get the negative 10x back. The negative 5 times negative 1 is positive 5. So these factors are correct for the second group. And then for step 3, we will factor the common from the expression. So from the two big groups, the common factor is that binomial 2x minus 1. So I'm going to pull it out. So 2x minus 1 is now here. And for the second factor, I put two blanks because since I have binomials in here, I should have a binomial also in the second factor down here. And then to collect the remaining terms after removing the common factor from the group 1 here, x squared I should copy down here. And for the second group, the negative 5. So for step 4, I'm going to check by multiplying the factors. So the 2x times x squared, the answer is the 2x cubed. 2x times negative 5, I will get the negative 10x. Then negative 1 times x squared, it is negative x squared. Negative 1 times negative 5 is positive 5. So we are now sure that our answer is correct. Let us have example 3. Factor out 2x minus 9y plus 18 minus xy. So let us group terms with common factors. If I group the 2x minus 9y, there is no common between these two terms. Also, the 18 minus xy, if I group these two, there is no common factors for these last two terms. So what I'm going to do is to rearrange the terms. I can put the 2x on the last part. So it's now negative 9y plus 18 minus xy plus 2x. And then from here, I can see now that there is a common factor in the first two terms. Also, there is common in the last two terms. So it's now the quantity negative 9y plus 18 plus. So again, I see here that the third term is negative xy. So I must be careful. I should put here the plus and put the grouping symbol for the negative xy plus 2x. And step 2, factor out the common factor. In the first group, the common factor is 9. But I want this variable y to be positive, so I should pull out negative 9. And if I do that, the remaining terms inside here should be y minus 2. Now, to check myself, the negative 9, if I multiply it by y, I will get back the negative 9y. The negative 9 times the negative 2 equals positive 18. So I'm sure that these factors are correct for the first group. Now for the second group, I want that y to be positive also, so I should factor out a negative x. So what remains here now is positive y and then negative 2. So let us check again if the factors are correct. I'm going to multiply negative x by y. It will be negative xy. The negative x times negative 2 will be positive 2x. So I'm sure now that these factors are correct for the second group. And for step 3, let us factor the common factor from the expression. So the common is the y minus 2. It is now down here. And for the second factor here should be a binomial. I will simply collect the terms that will remain after removing the common factor. For the first group, the negative 9 will come here. For the second group, the negative x will remain, and I should copy that down here. And for the step 4, I should multiply the factors to check if it is correct. So y times negative 9, I will get the negative 9y. Then y times negative x, here is the negative xy. Negative 2 times negative 9, I will have this positive 18. Negative 2 times negative x will be positive 2x. So now I am sure that my factors here are correct. And this is our final answer. Let us have example 4. Factor out x squared minus 6x plus 9 minus y squared. Step 1. Group terms with common factors. If I group the first two terms, I can see that there is common between them, and that is x. However, if I'm going to group the last two terms, there is no common for these two. So this is a special case. It is possible that I can group the first three terms. So x squared minus 6x plus y is now taken as one group, and then the negative y squared will be alone. And then this trinomial, I can factor it out into the square of difference of two terms. Then I will just copy the negative y squared here. In step 2, I'm going to factor out using the special product difference of two squares, and this is the formula. When we have a squared minus b squared, the answer will be the binomial a plus b times the a minus b. In this case, the x minus 3 is considered to be the a, and the y is the b. So in applying this formula, it will be like this. So the a, the x minus 3, I will copy here. Then first I'm going to put the plus sign, and then the y. And then multiplied by the quantity x minus 3. This is the a again. And then this time should be minus, and the y. And then I'm going to simply remove the grouping symbol inside the square brackets. So the parenthesis inside is now removed. So these are the factors. So step 3, we're going to check by multiplying the factors if these are correct. So if I'm going to take one term each from this group and to multiply to the other group, this will be the product. So x times x will be x squared, x times negative 3 is negative 3x, x times negative y is negative xy. Next is negative 3 times x is negative 3x, negative 3 times negative 3 is positive 9, negative 3 times negative y is positive 3y. Now for the y, times x is positive xy, then y times negative 3 equals negative 3y, and y times negative y equals negative y squared. And from here, let us see some terms that we can combine or cancel. This negative xy, there is a positive xy down here that we can cancel both of them. Also look at the positive 3y. There is a negative 3y in here, so both terms are cancelled. And then we will collect what will remain, the x squared. Then we have this negative 3x and negative 3x. Combining them, we'll get the negative 6x. We will copy the 9 and the negative y squared down here. So you see, the final answer here equals our original problem. So it means this trinomial and another trinomial here is our final answer. I hope you learned something from this video. See you again next time.